In Lesson 3.6, we're going to be looking at solving equations involving rational numbers. So we're going to be using the same rules and properties we've been using with rational numbers, but now they're going to be contained within equations. Let's remember the goal of an equation itself is isolating the variable and using inverse operations to do so. So in example 1a, we automatically note that y is being increased by 17.3, making the inverse operation subtraction. So we would subtract 17.3. Whatever you do to one side, you must also do to the other. So we're going to subtract 17.3 from both sides of the equation. That will isolate y on the left. On the right, we have a negative number minus a positive number. So integer rules to remember. If we're thinking of this as subtraction, we know we can change subtraction to addition and switch the sign of the second integer, which would really make us now have a problem where we're adding a negative to a negative. So now we can line up the decimals. Now you might be saying the first number doesn't have one, but you can make any whole number a decimal by just adding a 0 into the decimal places. So since our second number only goes into the tenths place, I'm just going to add a 0 in the tenths place, and now I'm going to bring my decimals straight down. 0 plus 3 is 3, 2 plus 7 is 9, 4 plus 1 is 5, and again my answer is negative because we were adding two negatives. So my final answer, y equals negative 59.3. In letter B, we have negative 2/7 plus k is equal to negative 5/7. So the operation that is occurring is addition. So our inverse operation is subtraction. We do not change the sign of the first number. So we will be subtracting negative 2/7 from both sides of our equation. When we subtract the negative 2/7, it will cancel, leaving us with k. And on the right-hand side, when we take negative 5/7 and we subtract a negative, what we're actually doing is adding a positive. Now we're adding two fractions with the same denominator, so we really only have to focus on the numerators. So if we have a negative 5 plus positive 2, that's going to bring us to negative 3, and our denominator stays the same. So our final answer will be negative 3/7. In example 2, we have t plus 5/13 is equal to 7/26. So our inverse operation is subtraction. So we will subtract 5/13 from both sides. That'll isolate our t on the left. However, on the right, we have a slight problem because 5/13 and 7/26 are not common denominators. We can easily see, however, that 13 is a factor of 26. So if I just multiply the numerator and denominator by 2, I will get a like denominator. So I will have 7/26 minus 10/26, which will leave me with t, just going to move this up, t is equal to negative 3/26. And that is fully simplified, so we'll leave it as is. In letter B, we have r minus 13.8 is equal to 56.9. Because our operation is subtraction, our inverse operation will be to add 13 8/10 to both sides. It will cancel on the left and isolate our variable r. And on the right-hand side, we line up our decimals and add straight down, bringing the decimal down first. So 9 plus 8 is 17. We carry the 1. 6 plus 3 is 9, plus 1 is 10, so we carry a 1 again. And then 1 plus 5 plus 1 is 7. So we get an answer of r is equal to 70 7/10. Now you'll notice in example 3, we now have fractions equations that involve multiplication or division. So same process, we're still using inverse operations, but we're going to have different ones that we're trying. So let's go ahead and start with example 3, letter A. So we have negative 2.3f is equal to 16.1. So our inverse operation here will be division. So we will divide both sides by negative 2.3, since that is the inverse operation of multiplication. The sign of our number does not change. So on the left it will cancel. And on the right we make note that we have a positive divided by a negative, which means we will get a negative answer. And to do our division of decimals without a calculator, we're going to do long division. So the main thing that you want to remember is you never want to divide a decimal. You can divide a decimal, you don't want to divide by a decimal. So in order to do that, we can actually change each of the parts of this problem by multiplying both by 10, which essentially doesn't change the value but just moves the decimal over one. So when we do that, the problem will actually become 161 divided by negative 23. So if we do our long division problem, 161 divided by 23. Now, I might not be able to figure out exactly how many times 23 goes into 161 initially. So I want to think through if we chose 8. 8 times 20 I know is 160. So that's going to be too high. 20 times 7 is going to be 140. So that may work. So let's start with trying 7. Sorry about that. Then we can multiply 7 by 23. Carry the 2. 7 times 2 is 14, plus 2 is 16, and we get a remainder of 0. And so that tells us that our final answer will be F equals negative 7. There was no need to worry about the decimals. You already took care of that at the beginning. In example B, we have 5/6D equals 7/18. So our inverse operation is going to be division. So we will divide both sides by 5/6. That will isolate D. When dividing fractions, the main rule is keep, switch, flip. Some of you might remember it as keep, change, flip. But you're going to keep the first fraction, 7/18, switch division to multiplication, and flip your second fraction, which will be 6/5. Now in this case there is some cross simplification that can happen because 6 goes into itself once and into 18 3 times. So now if you multiply straight across, you will get 7/15, which is our final answer here. So D equals 7/15. In example 4, M is being divided by 4.5. So the inverse of division is multiplication, so we need to multiply both sides by 4.5. We immediately notice that there's a negative on the right-hand side, so we know our answer will be negative. But we're going to need to multiply out 4.5 by 5. So we start with the longer number on top, which will be the 4.5, and then 5 can go beneath it. We move the decimal over one place to make these both whole numbers, and then we multiply normally. So 5 times 5 is 25, carry the 2, 5 times 4 is 20, with 2 added on is 22. Then we move our decimal back in one place, which will make our final answer, M is equal to negative 22.5. In the last one, 4b, 1/6 C is equal to 9/24. So again, our inverse operation will be division. So we'll divide both sides by 1/6 to isolate C. and we will write out the division problem again, keeping in mind that we need to keep switch flip. So we will keep 9/24, switch division to multiplication, and flip 1/6, so it is now 6/1. And again, we can cross simplify. 6 goes into itself once and into 24 4 times. So when we multiply straight across, we will find that C is equal to 9/4. Now that is an improper fraction, but it does not need simplified, so we're fine to leave it as our final answer. So C equals 9/4.